Welcome to Get Your FRQ On. This question comes from the 2014 AB exam. It's question number 5, and it is not calculator active. In the question stem, we're given a table of values for a function f of x, its derivative, a function g of x, and its derivative, selected values of x, and included in the table is some information about the behavior of those functions between the given values. For part A of the question, we are asked to find all x on the interval from -2 to 3, such that f of x is a relative minimum. All right, now the graph of f will have a relative minimum wherever the derivative of f is equal to 0 and changes from negative to positive. If it changes from positive to negative, it'll be a relative maximum. We don't want those. We want negative to positive. So we can check the table. Remember, when you justify and try to conclude something in one of these free response questions, it's always best to justify your conclusions based on the given information. It is one of the only things you know is true in this question. According to the table, the only time this happens is at x equals 1. In part B, we are asked to explain why the second derivative of f evaluated at some value of c between -1 and 1 must equal 0. All right? Since f is twice differentiable, that's given to us in the question stem, f of x and f prime of x are both continuous on the closed interval from -1 to 1. Since the derivative of f is continuous, and based on the table, f prime of -1 and f prime of 1 are equal to each other, the mean value theorem guarantees the existence of the value c, some value c, between -1 and 1. Right, so there is this value such that the second derivative of f evaluated at c, so f double prime of c, is equal to 0. In part C, we are defining a new function, h of x equals the natural log of f of x, and we are asked to find h prime of 3 with computations. While h is defined as a composition of two functions, it's the natural log of f of x, so in order to find h prime, we're going to use the chain rule. H prime of x would be the derivative of the natural log function applied to f times f prime of x. While the derivative of natural log is 1 over x, so we would have 1 over f of x times f prime of x, which is just f prime of x over f of x. Please be careful, that does not reduce at all. Don't cancel anything out and just think that the derivative is an apostrophe. We're not freshmen here. It follows from the table provided that h prime of 3 would have to equal 1 over f of 3 times f prime of 3, and then just substituting the values from the table, we have 1/2 over 7, which is 1/14. Right? So h prime of 3 would be 1 over 14. In part D of this question, we are asked to evaluate the definite integral from -2 to 3 of f prime of gx times g prime of x dx. Right, now, it might not seem obvious, but the structure of this integral is such that the integrand is the result of a chain rule application. In fact, if you think back to the chain rule when you first learned it, if you differentiate f of g of x, that's f prime of g of x times g prime of x. It's literally the exact same expression. All we're doing is reversing that. Remember, anti-differentiation is the inverse of differentiation, and differentiation is the inverse of anti-differentiation. So, the antiderivative of f prime of g of x times g prime of x dx should just be f of g of x. Right? That's critical because now we can use the fundamental theorem of calculus. So the definite integral from -2 to 3 would just be f of g of x evaluated between 3 and -2, and then find the difference. Right, so f of g of 3 minus f of g of -2. Using the table, that just comes out to f of 1 minus f of -1, which turns out to be -6.